Good morning, everybody. Welcome to Natural Science. We're on grade 8. We're doing revision for term 2. Our topic today is subatomical particles. My name is Arifa Hafichi, and if you have any questions, you're welcome to raise your hand or type it on the chat, and I'll have a look at it. Today, we're going to learn more about protons, neutrons, and electrons and how they function in an atom. And I'm also going to teach you how to calculate the protons using a periodic table. For example, if they give you a table in your exam and they ask you how many protons does this element have, for example, then I'm going to show you how to answer that question. So a quick recap on yesterday's lesson. We learned that all matter consists of atoms and that atoms of different elements combine chemically to form compounds. That means through a process of chemical reactions, they combine and it would form a compound. Now, elements and compounds are pure substances because they only consist of one type of atom or molecule. Remember, a molecule is a combination of atoms. All objects that we see and the food that we eat, even the air that we breathe and our own bodies, these are all examples of matter. You must know that matter takes up space and it has mass, and you get matter in three forms: a solid, a liquid, and a gas. Now, matter is a name given to anything that atoms are the building blocks of matter. And atoms are very small and it cannot be seen with the naked eye. Even the most tiniest of atoms, a single atom, you won't be able to see it. Now, atoms are indivisible and it cannot be created, nor can it be destroyed during a chemical reaction. It just takes a different form. And we also learned that although everything is made up of atoms, they are not all the same. Now, before I do a revision of Dalton's postulates on the next slide, does anybody remember what they are? You can either type it in the chat or you could raise your hand and my host will unmute you. Just give me 3 of his postulates about atoms. Does anybody remember? I did go through it here. Anshla, don't you want to try? Nobody. Okay. So let's see you. Okay, so let's see. Dalton's postulates. Each element consists of indivisible, minute particles called atoms. All atoms of any given element, they are identical in nature. That's because it would be a pure substance. That's when it would be identical in nature. And then atoms have different elements. They have different masses as well. And then you know that atoms can neither be created nor can they be destroyed during a chemical reaction. So today's lesson, I'm going to recap on subatomic particles of what we discussed in our previous lessons. So we know that an atom is made up of subatomic particles, and these particles are protons, neutrons, and electrons. Now, the protons and the neutrons are situated inside the nucleus of an atom, and I'll show you the picture of it in the next slide. And then the nucleus is basically the center of the atom. And we have electrons that orbit around the nucleus. Okay, and they orbit in harmony with the protons. So as the protons move, then the electrons also move in harmony. Now the protons are positively charged and the neutrons have no charge. This means that they are neutral. And we say that the electrons are negatively charged. So a neutral atom has the same number of positive and negative charges. So this basically means that when the number of protons equals to the number of electrons, then the atom is neutral. Okay, before I go through it on the top, look at the picture just so that you can understand. So this is the nucleus of an atom. Look at the picture and you will see that there's protons and there's neutrons inside the nucleus. So the lighter orange ones with the plus signs are the protons and the one with no signs are the neutrons. And the neutrons are there basically to protect the protons from each other because it acts as a buffer. Because like charges repel, so we don't want them bumping against each other, so it protects it. It like serves like a cushion. And then you will see the negative charges on the outside of each shell or energy level are the electrons, and these are the electrons that orbit around the nucleus. So we have the subatomic particles in an atom are protons, the neutrons, and the electrons, which I just showed you. And the protons and the neutrons, they are found in the nucleus of the atom. So you could see here, I showed it to you. Now the electrons basically move around here. And the protons have positive charges and the neutrons have negative charges. So when it has a negative charge, it means it is negatively charged. So, and also to recap, the neutral atom has equal number of protons and electrons. So when it is equal, we say that the atom is neutral because it has no charge. So who is going to answer this question for me? What are the two subatomic particles that are found in the nucleus of an atom? Anybody want to try? You can raise your hand. Nanshlanshla?
It's called a neutron and a proton.
Okay, very good. Even Erin as well, she said they are the protons and the neutrons. Well done to both of you. Then what is the charge of an electron?
Charge.
Anybody wants to try? What is the charge of the electron? So look at the picture here. Okay, Jean Luck, I think, I hope I pronounced your name properly. You said that it is negative. Well done. Even Samakushle, very well done. So that is negative. Well done for that. So then we say the subatomic particles in the nucleus are protons and neutrons, and the charge is negative. Then let's see, how do we know that an atom looks like when we cannot see it even with the strongest microscope? Now, scientists have developed a model of atoms based as a result of the experiments that they did in terms of watching the behavior of atoms. So this is one of the ways that they developed properties and characteristics of atoms by observing its behavioral characteristics. Then we have an atom of protons and neutrons and electrons. They do not exist on their own. So that means that they exist with something else. It just doesn't exist on its own. And then the protons are positively charged, and the electrical, electrical neutral particles are neutrons, and they are tightly packed in the nucleus. And the nucleus basically has an overall positive charge because the neutrons does not have any charge, it's just the protons. And then the protons and the neutrons together are called nucleons. Right. Then in nucleus, the nucleus is positively charged sphere at the center of an atom, and it is positive, as I repeated above, only because the protons are there and the neutrons don't have a charge. So by me going through this and repeating it, it actually helps you understand it, and you'll be able to actually remember it as well. So when you go back to school and if you have to do tests, you won't be doing an exam, but you'll be doing tests on certain sections to make up your mark for the end of the year, then you'll remember it very well. Then electrons move at very high speeds around the orbit. Remember I told you yesterday that they form an electronic cloud because they're moving very, very fast. And this electron cloud is much bigger than the center of the nucleus. And we know the atoms are neutral because the negative charge of an electron is equal to the positive charge of the proton. And the overall charge of this atom that is neutral will be zero. So it cancels each other out and the overall charge would be zero. Now let's look at this hydrogen atom. This is a simple atom and it only has one proton, one electron, and it does not need a neutron. And the reason why it doesn't need a neutron in the middle is because it doesn't need a buffer to protect it against another neutron. So look at this proton here. There's one in the nucleus, and then look at the electron on the outer energy level. Can you see that orange one? So basically this proton here and this electron, they move in harmony. So as the electron orbits, then the neutron, it's orbiting exactly in harmony with the specific proton. And now how to interpret the periodical table. So this is a symbol that I copied from the periodical table of hydrogen. So it's H. And can you see one above it? Now this one above this hydrogen means that it has one proton. So every time you see a periodical table and whatever number is above, it means how many protons that specific element has. So in your test, when they tell you, look at the periodic table and tell me how many protons a silver element has, for example, then all you do is you look at the top of the element that is here, the atomic number, and it will tell you, you just read that and whatever the number is, it will tell you how many protons are there, what they are. Okay, now I'm going to teach you how to read an element in the periodic table. So let's look at helium here. The symbol for helium is He, and we have an atomic number. So this atomic number means, this 2 here, it means that the number of protons in the atom. So sometimes if it's not on top, because different periodical tables are arranged differently, it would be on the top right-hand corner here. And then at the bottom, it gives you the atomic mass. Now, the reason why it is 4 is because it has 2 protons and 2 neutrons in the atom. So it has an atomic mass of 4. So you just multiplied this with times 2 and we got the atomic mass. Now, a hydrogen atom, as we saw in the previous slide, it has 1 proton and 1 electron. Now, who can guess what the atomic number would be? You can either raise your hand or you could type it in the chat. What would be the atomic number? We did do it in the previous slide. In the previous slide, it was written here on the top. Does anybody want to try? Yes, what's the atomic number of the hydrogen atom, a hydrogen element? Very good. Well done, Erin. So it is 1. Also, Lasidi and Nashanshla and Rafilo. I hope I pronounce your names properly. If I don't, please forgive me. An element is a substance that is made entirely from one type of atom. Okay, so that would be a pure substance. So the number of electrons, you must really remember this as I have here in the bottom. The number of the electrons is equal to the number of the protons. That's in pure substances. Now let's look at the carbon atom. Now you'll see it's different from the hydrogen atom that I showed you. Now in this carbon atom, so if you look here at the symbol before we look at the atom itself, you'll see a 6 above it. So this 6 is the atomic number, and it means that it has 6 protons inside. So look at the nucleus now, and you can see 1, 2, 3, 4, 5, 6. So it has 6 protons. And now because it has 6 protons, it has 6 neutrons. So it equalizes the nucleus. And then on the outer shells, or the outer energy levels, we have 6 electrons, which is 1, 2, 3, 4, 5, 6. And they all orbit around. That means it moves around. It's in constant motion. And you remember I told you about that electronic cloud? Because it's moving around so fast, can you see my cursor here? It's going fast. So because it's going around fast like this, it forms an electronic cloud, and it would be much bigger than the nucleus. So a carbon atom basically has 6 protons, 6 neutrons, and 6 electrons. Now, protons are deep inside an atom, and this is called the zone. This zone is called the nucleus. Now, protons are said to be positively charged. Now, you can ask yourself, what does that mean? It's positively charged. Now, to think of this, to answer this question, think about the following phenomena that scientists have observed. So they developed this phenomena because of their observations. So they observed that when an electron gets near a proton, they attract each other. Okay, and when two electrons uh, uh, push away from each other, when they get close to each other, they push away from each other. So when two protons get near each other, they also push away from each other. So these were their deductions. They had separate deductions about how an electron reacts with a proton, how two electrons react together, and how two protons react together. And then they decide they now they doing the observations, and they are theorizing and they formulating their theory now after they observed. So what causes this? There are some properties of electrons and protons that make them apply certain forces. So from this observation, they deduced that now this occurred because of some force that was either attracting or repelling each other. So scientists use the word charge to represent the property that these particles have. So they said that it is positively charged and negatively charged. So what the protons, P for protons, positively charged, and the electrons were negatively charged. So their deductions and through their observations were, and you need to learn this very well, like charges repel each other. That means that they push away from each other. And opposite charges, they attract each other. Now, you know how the common saying between boy and girl, they always say opposites attract. So you can remember it like that. The opposite, which is the proton and the electron, they attract each other. And because protons are two of the same, they repel each other. Also, electrons are two of the same and they have charges, they repel each other. Now you'd ask yourself the question, now why doesn't that apply to the neutron? And this is because the neutron doesn't have a charge. Can you see the word charge? And the scientists applied to it. It does not have a charge. So it neither attracts or repels. This is the neutron. It is just neutral. So I'm going to explain neutrons and electrons to you. Now, neutrons are particles that are neither positively or negatively charged. So we say that they are neutral. So the neutrons together with the protons form a tightly packed nucleus at the center of the atom. Remember that I told you that it serves as a cushion for the protons. And the nucleus is very, very dense. Now, because it is tightly packed, we say that it is dense. Now, the protons and the neutrons, because it's very dense and it's tightly packed, it becomes heavy for their size. Now, I'll explain again electrons. So electrons are the smallest of the three subatomic particles. They are about, just want to move this, they are about 2,000 times smaller than protons and neutrons. Now, electrons move in a zone around the atomic nucleus at extremely high speeds. And I showed you in the atom of the, I think we did the carbon atom. I showed you how it moves. So it moves at extremely high speeds and it forms an electronic cloud, which is much larger than the nucleus. So you look at the drawing and you can see the model, you'll be able to understand the model of the atom. Now you can also draw your own atom. You can use the information that I gave you and from the previous slides, you can look at the periodic table, you can do it as homework and you can draw an atom. Now the fact that you're going to draw it, it puts things into perspective for you and if you learn, be able to learn and it will go into your long-term memory because you're actually applying what you learned. So you can look at the periodic table. You can Google one on your phone as well, or you could look at, you can download these slides of mine and you can look at it and select any element that you want and then draw a nucleus. You can use your Prit if you want to draw a small circle, you know, the Prit head. And inside, you can draw the number of protons and an equal number of neutrons. And then on the outside, on the orbit, on each energy level or the shells, you can draw the negatively charged electrons, sorry. And the fact that you're going to be doing this, you're learning how many protons are in an element and you're learning the arrangement of it. And while you're learning this arrangement, you can state its properties of how they positively charged, how they negatively charged, how the electrons form a cloud. So it's your way of understanding and learning visually and through diagrams. And the other way is to actually write the information down. So when you write it, when you're going to write questions that are like 5 or 6 marks, and because you're going into higher grades, they're going to ask you essay type questions. You're developing your writing skills. So here's the picture of the periodic table. So you can see they are all in rows and in the rows going vertically, and then we have the periods going horizontally. Now, do you remember Dalton's postulates? So they were, each element are indivisible and minute. Atoms of an element are, of a specific element are identical, and atoms of different elements have different masses. Like for example, this hydrogen element here has an atomic mass of 1. Then this lithium, it would be 3. And then we have this sodium is 11. Now, each element in the periodic table has its own type of atom. The atoms of different elements are different as they have a different number of protons in them. Now, you remember that we said that atomic number of an element tells you how many protons each element has. So we're looking at the atomic number to see how many protons it has. So let's look at this Mn here. And it's 25 above it. Now who can tell me how many protons is in that element that I'm pointing to here? You can either raise your hand or you can type it in the chat. So look at my cursor, it's pointing to Mn here. There's my cursor. So it has 25, the atomic number. So how many protons would that be? Anybody wants to try? Nobody. Okay, so that would be, it has 25 protons. And if it has, very good, this the, the can I call you Reef if you don't mind? And Nanshlanshla, well done. It is 25. Also Kaylee, 25. Well done. Okay, so I'm going to ask you questions in the next slide, and then you can also type it in the chat, or you can pick your hand up. So if we wanted to make a model of the nitrogen atom, how many protons would you need? So let's look for nitrogen. So nitrogen is a symbol N, and let's look at that. How many protons would you need? 7. Sean Locke and Lucidi said 7. Well done. That's absolutely correct. Now, a quick question before I move on. So look at the periodic table. So you could see it's categorized in yellow, purple, and green. So even though the answers are on, you can type it out. Which one is the metal? You can give me the color. In this periodic table, which elements are the metal? Which color? Is it the yellow, the purple, or the green? Well done. Nanshlanshlan, Erin, and Kaylee, and Ripoli. It is yellow. Then the metalloids are semi-metals. What color is that? Very good, Nanshlanshla, Erin, Jean-Claude, Lasidi, Kaylee. Well done. So it is purple. And MJ, and now the non-metals, what color is that? Green. Well done, Miss Siri, Erin, also John Luck, MJ. Right. So now the fact that you wrote it down in the chat, it means that you're learning. You're using it to learn because you already now know how to categorize a periodic table into metals, metalloids, and non-metals. I'm very proud of you. Well done for that. So now, if we said that the nitrogen was 7. Now, if you wanted to make a model of sulfur, how many protons would we need? So we're going to look at what sulfur is. Now, sulfur is a symbol S. So let's look at S. How many protons are there in S? Now, I can give you a clue when you're going to look. Well done. Okay, Jean-Claude, Lasidi, NJ, and Shlanshla. It is 16. Okay, also NQT and Nikon. Right, well done. So it is 16. So there are 16 protons in a, a sulfur atom. Now, in most of the elements, the number of the neutrons in the nucleus is the same as the number of the protons. So we say that the atom is neutral. So in this nitrogen atom, there's 7 protons. This means that there are 7 electrons. This makes it a neutral atom. And then the sulfur, it would have 16 electrons, and it makes it a neutral atom. Element as well. So I'm going to summarize. We finished a little early because I wanted to conceptualize the information so you can understand it, have a good grasp of, and develop this foundational knowledge for it. So we say atoms are the building blocks of matter, and atoms cannot be divided into smaller particles, nor can they be destroyed in a chemical process. Now, atoms are made up of 3 different kinds of subatomic particles, and this is protons, neutrons, and electrons. Now, the central region of the atom is called the nucleus, and the nucleus is made up of positively charged particles called protons and neutrons, and these together makes it neutral. Then we have negatively charged particles. They are called electrons, and it orbits around the nucleus. Now, atoms are neutral because the number of the negatively charged particles, which are the electrons, is equal to the number of the positively charged particles, which is the protons. Now, atoms are made up of three different kinds of subatomic particles. These subatomic particles are protons, neutrons, and electrons. They are found deep inside the atom in the zone called the nucleus. And here inside the nucleus, we have positive protons. Now, neutrons are there, are neither positive nor are they negative. They are neutral. And electrons is the smallest of the three subatomic particles, and these are negative charges. And electrons are arranged in the energy levels of the shells around the nucleus of an atom. And atoms make elements and they increase in atomic number as a periodic table. So because the atomic number increases, this means that the number of protons in each element is increasing. Okay, now you noticed on this slide, I put the information in different colors. And the reason I did that is because we all learn differently. Some of us learn through concept maps, some of us learn through writing, and then some of us learn through writing in different colors. Because it makes it visually appealing to us. And then once you look at all the different colors, you become happy, and then your mood changes towards studying and you'll be happy to study. So it's one of the techniques that my daughter used when she studied because she doesn't like to study. But when I give her color pens, then she's game on. She's happy to study. Okay, so all the information that I derived from this source was from ciovela.com and also nect.org, which is a Department of Education's website that gives you all the foundational knowledge you need to understand for this concept, and it builds on it when you go on to higher grades. Right, I did have an absolutely wonderful time tutoring you. Our next lesson I'd love you to join me on is on elements, discuss all the characteristics and how it works tomorrow. Join me, and if you'd like more information or if you'd like my slides, then you can contact me at ahaffea@gmail.com. Thank you, Kaylee. I will have a great day. Enjoy your day, everybody. Well done, and I will see you tomorrow. Bye, Nanshlanshla. Bye, everybody. Bye, Lasidi. Bye, MJ. And Joy.